Okay, in this lesson we're going to be talking about some right triangle trigonometry, but before we do that we need to talk about some just basic terminology of a right triangle. So let's take a look at our example here. So we can see we have a right triangle. We already know the hypotenuse is the side that is opposite from the 90-degree angle. So I can see segment AB, that's the hypotenuse. So I'm going to go ahead and label that. Now, the other two sides depend upon which angle we are referring to, or the reference angle. So notice in this diagram, I have angle A marked with a star. So what that means is that's our reference angle. So when I label the other two sides, they are in reference to angle A. So here's what I mean by that. If I'm looking at angle A and I look completely across the triangle to the opposite side, that across from the angle A, I have this side, line segment BC. Okay, it's completely on the other side of the triangle. In other words, if you put your fingers on angle A and you follow them down the two sides of the triangle, they would lead to segment BC. So because that's opposite from angle A, we call that the opposite side. And the other side that we have left, well, segment AC, that's the other side, it is right beside angle A. Beside, or we learned the term adjacent earlier in the semester. So segment AC is the adjacent side. Now again, both of those depend upon which angle we're referring to. So they'll change if I'm referring to angle B rather than angle A. So let's take a look at how that would look. So here we have another right triangle, but this time we are going to be looking at the sides in reference to angle B. So first of all, the hypotenuse is always the hypotenuse. We'll just label that. That is across from the 90 degree. So now I'm looking at angle B and I'm going to, either with my fingers or just with my eyes, I'm following angle B down on both sides, and that leads to line segment AC when I do that. So that means that AC is opposite from angle B. And lastly, the only one we have left is the adjacent, but let's look at why it's adjacent to angle B. Line segment BC is right beside angle B, which is adjacent. Now, oftentimes when we are referring to these three sides of a right triangle, we'll just use the first letter. So this is H, or actually mostly we use capitals, I guess. So capital H, opposite is capital O, and adjacent is capital A. So let's take a look at how we would use these ratios, which is what we have here. So a ratio, we remember, is a comparison of two numbers written as a fraction. So certain ratios deal with right triangles and their sides and their side lengths. So the first ratio that I'm going to introduce you to is called the tangent. That's just the name for this ratio that's relating the sides of the right triangle. So tangent is equal to, and when this says tan A, that's just an abbreviation for tangent, and A is just a specific angle. So if you remember back to our picture, we had angle A. So when this says tan A, that's just saying the tangent of angle A is equal to, and this is just the ratio, it's the definition for tangent. Tangent always equals the opposite leg divided by the adjacent leg. So let's see how we would use that ratio in this example. So take a look at our diagram here at the bottom of the page. So we have a right triangle. We have three sides that are marked, lengths 3, 4, and 5, and we're supposed to find the tangent of A. So if I'm finding the tangent of A, that means I'm focusing my attention on angle A. So tangent is defined as the opposite over the adjacent. So we have to look at the sides that are in reference to angle A. So just like we did before. So I'm looking at angle A and I'm going to figure out where the opposite side is. And usually when I do this, I just label it right on the triangle. So I'm going to go across from angle A. And when I do that, across from angle A is line segment BC. So that is the opposite. So I'm going to write O. And then the adjacent, well, it can't be the hypotenuse, it's the adjacent. So it's the one that's not the hypotenuse or the one that's right beside angle A. So that would be the one that's marked 4, that is the adjacent. So when I'm supposed to find the tangent of A, all I have to do is write the ratio. So on the top, or in the numerator, I put the opposite, which we just labeled in our diagram. That's the 3 length. So I'm going to write 3 on the top. And in the denominator, that's the adjacent leg. And we labeled that in our diagram. A is 4. So the ratio of side lengths for the tangent of A, angle A, is 3/4 or 0.75. Okay, so now we're going to do the same thing for the tangent of B, angle B. So I'm going to go back to my diagram, but now I'm looking at angle B instead. So if we want to, we can cross these off because now they don't apply anymore. They were in reference to angle A. So we're going to still look for the opposite. So I'm looking at angle B now, and I'm looking opposite of angle B, which takes me all the way across the triangle to segment AC. So that is opposite. And adjacent is the other side we're looking for with the tangent ratio. Adjacent to angle B is the one that's not the hypotenuse, and it's the one that's right beside angle B, which is segment BC. So that it's adjacent. So if I'm defining the tangent of B, remember that's opposite in the numerator. So opposite we just said is 4. And adjacent is in the denominator, and that is 3. So the tangent of B is equal to 4/3, which is the exact number. So we'll just leave it as 4/3. Okay, now, besides the tangent, there are 2 other trig ratios that we need to know and we'll use quite often, and they are sine and cosine. Now, let's look first just at tangent because we already went over that one. So tangent, we said, is the opposite divided by the adjacent. Now there's a funny way to remember that, and I'll talk about that in just a moment. But this is the one here on the right that we just went over, the tangent. So sine is defined as the opposite leg divided by the hypotenuse. And cosine is defined as the adjacent leg divided by the hypotenuse. So you can see 3 different trig ratios, and we'll use all of them for different reasons. So someone at some point, I don't know when, but a long time ago, realized that that might be a easy way to help remember these trig ratios because we're going to be using them so often that we need to know that the sine is equal to opposite over the hypotenuse, that the cosine is equal to adjacent over hypotenuse, and that the tangent is the opposite over adjacent. So someone came up with a funny little way of remembering them, and that is that we have this chief of trigonometry, this Indian chief, and his name is Sohcahtoa. Sohcahtoa. So is the first part of his name, and notice how it's spelled, S-O-H, S for sine. O and H are for opposite and hypotenuse. Remember, in the triangle, we put a capital L and a capital H. So sine, you can remember, if you remember Sohcahtoa, so is opposite over hypotenuse. Sine is opposite over hypotenuse. Ka stands for cosine, the C at least, and the A and the H, tell you in order. The numerator is adjacent, and the denominator is hypotenuse, A and H. And back over here, sine O and H. So then TOA, is the one we just looked at, is tangent, and that's TOA, TOA, and that's opposite and adjacent, and T stands for tangent. Okay, so just think of SO, CA, TOA when you're trying to remember what the trig ratios are. So we saw tangent ratio in action. Now let's take a look at the sine and cosine. So back to our same triangle we had before. This time we're going to find the sine of A. So sine, so, is defined as opposite divided by hypotenuse. So I'm going to set up a ratio here. And I'm going to look at angle A. So I'm looking at angle A and I'm going opposite of angle A. So opposite of angle A is 3. And then in the denominator belongs the hypotenuse, and we know that the hypotenuse is 5. So I'm going to go ahead and put the 5 in the denominator. So sine of A is equal to 3/5, or 0.6. Let's look at the cosine of A. So cosine of A, I'm still looking in reference to angle A. That didn't change, but now I'm looking at the cosine, which is CA, A adjacent over hypotenuse, H. And so I now want to look at the adjacent from angle A, which is the one right beside it, which is 4. That's my numerator. And the denominator is the hypotenuse, which we said was 5. So the cosine of A is equal to 4/5, or 0.8, 8/10. Okay. So now we're going to look at the sine and the cosine of angle B. So again, I'll ignore these markings, I'll cross them out. I'll keep the H though because that doesn't change. But now I'm looking in reference to angle B. So when I'm looking for sine, I'm looking for opposite O divided by H. So I'm going to go ahead and put the hypotenuse of 5. But when I'm looking for the opposite, remember now I'm looking at angle B, that's my reference angle, so I'm going opposite from angle B, or across from, which is 4. So the sine of B is equal to 4/5, which coincidentally, well, it's not actually a coincidence, but notice the sine of B is the same as the cosine of A. Okay. Lastly, we need cosine. Cosine, CA, is defined as adjacent divided by hypotenuse. So we already know the 5 is going to go in the denominator. And now we need to figure out what the adjacent side is. So back to our triangle, and we're looking at angle B. Adjacent to angle B is the 3. So the cosine of B is 3/5, or 6/10, which again, notice is the same as the sine of A. And that's how we use our trig ratios. So that's how we set up the trig ratios. In the next lesson, I will show you how we use those trig ratios to help us find side lengths of a triangle.